So welcome to the second class on Laplace transforms. Here you will learn how to solve problems using Laplace transforms, and you're also given some formulas which will help you in problem solving. So stay tuned to the end. So we start with the first question. Find LFT if ft equal to cos t minus 2 pi by 3 when t is greater than 2 pi by 3 equal to 0 when 0 less than t less than 2 pi by 3. Now LFT is given by the formula integral 0 to infinity e raised to minus st ft dt. That would be 0 to 2 pi by 3 e raised to minus st ft dt plus 2 pi by 3 to infinity e raised to minus st ft dt, because that's how it's defined. And this part is 0 for t lying between 0 to 2 pi by 3. So this would be integral 2 pi by 3 to infinity e raised to minus st cos t minus 2 pi by 3 dt. Now we integrate by parts here. So this is u integral v. First of all, we change the order to trigonometric and exponential. And that will be cos t minus 2 pi by 3 integral of e raised to minus st, which is e raised to minus st by minus s, within the limits 2 pi by 3 to infinity, minus integral 2 pi by 3 to infinity, derivative of cos t minus 2 pi by 3 is minus, sin t minus 2 pi by 3 into e raised to minus st by minus s. So the three minuses will give you a minus here. And this will give you 1 by infinity is 0, and this will be minus cos 0 e raised to minus s 2 pi by 3 by s. Again the two minuses will give you plus. Take out the 1 by s here, so you get minus 1 by s integral 2 pi by 3 to infinity sin t minus 2 pi by 3 e raised to minus st dt. And that would be e raised to minus 2 pi s by 3 minus 1 by s. Again integrate by parts. So sin t minus 2 pi by 3 e raised to minus st by minus s. Integral of this within the limits 2 pi by 3 to infinity minus derivative of sin t minus 2 pi by 3 is cos t minus 2 pi by 3 into e raised to minus st by minus s. So the two minuses will give you plus. And that will be e raised to minus 2 pi s by 3. This whole thing becomes 0 because sin 0 is 0 and 1 by infinity is 0. And this will be 1 by s, and if I take out the s here, s squared here, you get the same function which you got in the beginning, that is I. So it becomes minus 1 by s squared I. So take the terms in I together. So 1 plus 1 by s squared I equal to e raised to minus 2 pi s by 3 by s. 1s gets, take the LCM, so s squared plus 1 by s squared I equal to e raised to minus 2 pi s by 3 by s. 1s gets cancelled, so I equal to s by s squared plus 1 e raised to minus 2 pi s by 3. Now I'm going to give you a table of Laplace transforms which will be useful in problem solving. So if the function is a, Laplace function of a is a by s. E raised to at is 1 by s minus a. Cos hyperbolic at is s by s squared minus a squared. Cos at is s by s squared plus a squared. Sin hyperbolic at is a by s squared minus a squared. Sin at is a by s squared plus s squared. Laplace function of t raised to n is gamma n plus 1 by s raised to n plus 1. T raised to n Laplace function is n factorial by s raised to n plus 1. So you can use these in problem solving. So coming to problems, find the Laplace transform of ft equal to cos hyperbolic 3t. Now cos hyperbolic 3t is e raised to 3t plus e raised to minus 3t by 2 the whole squared, a plus b the whole squared. So this is 1 by 4 e raised to 60 plus e raised to minus 60 plus 2. And now applying the formula, Laplace function of e raised to at will be 1 by s minus a. So this will be 1 by s minus 6 plus 1 by s plus 6. Laplace function of a is a by s, so plus 2 by s. Next question, find the Laplace transform of ft is e raised to minus 2t sin hyperbolic 4t. Now sin hyperbolic 4t is e raised to 4t minus e raised to minus 4t by 2. Open the bracket, so you get 1 by 2 e raised to 2t minus e raised to minus 6t. Applying Laplace transform, you get 1 by 2, 1 by s minus 2 minus 1 by s plus 6, because Laplace function of e raised to at is 1 by s minus a. Next question, find the Laplace transform of ft equal to sine 5t cos 2t. Multiply and divide by 2, so you get 1 by 2, 2 sine 5t cos 2t. 2 sine a cos b is sine a plus b plus sine a minus b. So that will be sine 7t plus sine 3t. Laplace transform of sine at is a by s squared plus a squared. So this Laplace transform of this would be 1 by 2, 7 by s squared plus 49 plus 3 by s squared plus 49. Coming to the last question for this class, find the Laplace transform of cos t, cos 2t, cos 3t. We first take cos t, cos 2t together and multiply and divide by 2. So you get 1 by 2, 2 cos t, cos 2t. 2 cos a cos b is cos a plus b plus cos a minus b. So that will be cos 3t plus cos t. And now you multiply by cos 3t here. This is cos 3t. So it will be 1 by 2 cos 3t plus cos t into cos 3t. And when you multiply, you get 1 by 2 cos 3t plus cos t cos 3t. 2 cos a cos b is cos a plus b plus cos a minus b. So that will be cos 60 plus cos 6t plus cos 0 plus cos 4t plus cos 2t. And Laplace transform of cos at is s by s squared plus a squared. So this would be 1 by 4 s by s squared plus 36 plus this is 1. So 1 by s, that would be the Laplace transform, plus s by s squared plus 16 plus s by s squared plus 4. So thank you and stay tuned for the next class. Thank you.